this is what I mean by paper space, model space to setup. There's two drawing types so far. There will be one more, but so far there's two drawings. There are many more drawings. We're going to talk about this at length next semester when we do MED, but I'm just going to concentrate on the two main ones. There are plan and profile, which we did, and we're not done yet, but which we're starting to create. So the drafting is ready. We have a plan, we have a profile, but not everything is complete. We haven't designed the pipes yet in the plan. We haven't put the pipes in the profile yet. But the view, the sheet is ready, plan profile. So there's the plan profile sheet, right? It's got the plan view of the road and the profile of the road. The purpose of this drawing when it comes to engineering and construction, the contractor uses this drawing to actually build all of the services. So sanitary sewer, all the information they need is here. Storm sewer, all the information is here. Water main, all the information is here. And all the related items, right? So for storm, it's not just the pipe and the maintenance hole, but it's catch basin, it's head walls, anything related to servicing. Whether it's sanitary, storm, or water main, that's servicing. That's what we refer to as servicing. When it comes to the grading plan, the purpose of the grading plan is to do the earthworks. So they actually move earth based on this elevation plan, right? The proposed elevation versus existing. So in this drawing, they want to see all the surface features, right? So imagine you're walking on the actual ground. What would you see and what wouldn't you see? And basically, you would see any information related to the surface. Anything underground would not show. So no pipes, but you'd see the maintenance holes and the catch basins and the valve chambers. Anything that has surface access, right? You'd see those items, but anything that's actual ground, you wouldn't see on this. You can't see through the top of the surface, right, of the proposed or existing ground, depending on which one is showing. So that's the main difference between the two, right? Servicing, underground stuff, no grading, and grading shows all the surface stuff, no underground stuff. Okay. Oh, and the last thing for the plan and profile, they actually use the plan and profile to build the final surface of the road, right? Which will be close once the grading operation is complete. So the way I've got it set up now is everything in the viewport is visible based on what's in model space. So in model space, we have everything. We have the grading design, and it's not complete yet, right? But we have an elevation at the front, an elevation at the back. So that's the grading information. We have the existing ground information. That's the surface. So that's the surface. We have the maintenance holes. We have the pipes, right? And we're not done with the pipes yet, but when we are, you'll see all the pipe information as well. The length, the slope, the material, the size. We'll get into all that. Okay? The water main is showing and so on. So when you do your design, you want to see everything. You want to see the grading and the servicing together because you can't design one without the other. You kind of want to see what's happening with one while you're designing the other. So to see everything in the model space is convenient. In paper space, however, again, because of what you want to actually see in each drawing type, you have to manage the visibility, right? Now, I don't want to freeze and thaw everything in model space. I actually do that through the viewport. So let's go to the plan and profile. The other thing you don't want to see is anything you create to do your work. So for instance, nobody needs to see your corridor. Nobody needs to see the alignment for the gutters. Okay, that's all information you create for the purpose of the surface model of the road. Okay, it's not part of your presentation. Nobody sees that. It's implied in the design. It's not shown explicitly. So those are some other things you might need to take care of. Okay, so when it comes to that, this is how I do it. It's up to you. I don't need to see the labels for the crescent. I don't need to see the labels for the alignment of the cul-de-sac, right? The only centerline labels you need is the main road. That's all you're designing for. The other thing you don't need to see is the alignment itself, right? So this alignment in this drawing, I did the example at the edge of asphalt. And in this one, I did the example at the edge of asphalt instead of the gutter line, but it's equivalent. So these two, you can either put them on a separate layer, right? So I'm going to put them on the same layer as the corridor. Put them on the same layer as the corridor so that when I freeze the corridor layer, I will lose them as well. Okay, so you can freeze the corridor because you don't want to see it anywhere when you're done. You could freeze it right here. Okay, but if you want to keep it here, then you want to manage the viewports. So let's assume we want to always see the corridor in model space because we're working with it. Let's go to the plan and profile. So to do this effectively, you have to go into and make sure both windows are locked. Make sure the lock is on. Okay, because if you go in there and this is unlocked, you're going to screw up the scale. Then you'll have to start over. Right. So this is the problem. If you click on one and you turn the lock off and you go in there, when you zoom, you're going to screw up the scale. So to prevent that, what we do is we take both frames and we lock them both. And now if you go into the view window, when you zoom, it actually zooms paper space, not model space. Okay, so make sure you do that. So that's the first thing. So when it comes to the plan view, remember this is servicing. I don't want to see anything related to grading. So in here, I'm going to go into the viewport. I'm going to freeze. I'm going to use the same button you would in model space, freeze. But when I freeze this in model space, sorry, in paper space to model space, when it's frozen, if I go to my layer control and I go to my corridor, I didn't use this freeze command. I actually froze the layer in the window. So that's what I did by being in paper space through the viewport to model space. This is what I just did. Okay, so you want to make sure you do that. Now it's the same function. You could either do it here if you know the layer name, or you could just touch it through the viewport window. The pop-up windows don't show up again. Oh, why not? I know why. Because I'm not sharing my entire desktop. Let me try this again. My apologies. Sorry about that. Okay, so I'm going to go to my layer control, LA for layer. Can you see it now? My layer window? Okay, sorry about that. All right, so then if you find the layer called corridor, you'll see that I didn't use this freeze. If I freeze this, it's frozen everywhere. So I want that on so I can still see it in model space. I want to freeze in this column, viewport freeze. So the current viewport that I'm in paper space, but I clicked into the model space through the window. And when I use this, this icon here, it freezes it in the viewport, not in the entire drawing. And that's really the secret here. So I'm going to continue to do that. I'm going to use this freeze command. I don't want to see any points. So that layer, I want to freeze it in the viewport. This layer, I want to freeze it in the viewport. And anything else related to grading. And there will be other things. Later, we're going to produce the center line of the road, lots of other stuff. Okay, so we'll get into that when we do the grading plan. The other thing I don't want to see is the surface, right? So watch this. If I try and freeze the surface, it should freeze the layer that the surface is on. And that layer is on C10. And there it is. I just froze the layer that the surface is on. You can see it happening off to the side here. Okay, so you shouldn't see any grading information in this drawing. Okay, but everything else you should see. So you should see all the existing and proposed underground pipes, all the existing and proposed maintenance holes or hydrants or whatever you have. Okay, so that's really what the plan view looks like. The road planimetrics, right? Edge of pavement, center line of road, all that stuff, plus the underground service stuff. Okay, so that's here. If I go to my grading plan, I want to freeze again. I don't want to see the corridor, so I'm going to double click inside. Make sure your zoom has that lock on it. Let me just double check that. It looks like it is on. Make sure the lock is on so that when you go into the window, use that freeze command. I don't want to see the corridor. I don't want to see anything underground. Now here's the trick. If you drew your circles and your lines on the same layer, you're going to have to separate them. So if I freeze the layer that the pipe is on, I still see the maintenance hole. If I freeze the layer that the pipe is on, I still see the maintenance hole. So if you want to see that effect, you have to separate the maintenance holes, a surface feature, from the pipe, an underground feature. Otherwise, you won't get that effect. Okay, and then I don't want to see the water main either, so I'm going to freeze the water main. Anything underground should not be visible here, only the surface information, and that's a grading plan. Okay? It would include labels for the contours and so on. Okay, and it's not complete yet. We're just getting ready. We're going to add a whole bunch of points between the front and the back. That's assignment 4. We'll get to that after the break, right? Where we're certainly going to start that discussion today. So that's how you manage your layers. In model space, you see everything. Servicing and grading, right? You see the pipe, you see the corridor, you see the points, everything is here. So you can continue to do your work in model space, but this drawing is ready to print and this drawing is ready to print. The only problem that you run into if you do this now, which I'm asking you to, is as you add more layers, by default, they'll be visible everywhere. So then you may have to go into each viewport and make sure, oh, did any new grading information show up in the plan profile? Or did any new underground information show up on the grading plan? So you may have to manage that on the fly as you create more and more data. If you have a template and you have plan profile sheets generically, and grading sheets generically set up. The layer control is pretty much already set up for you. So some companies actually create that. And all you have to do is put the view in the right spot, right? Set up the view, but the layer control in the viewport, they created for you, and the layer control is already set up. Did you say that you don't need to have the corridor in model space? You could leave it in model space, but you don't want to see it in paper space. Okay. When you produce these sheets, nobody knows whether you used AutoCAD or Civil 3D or if you drew it very neatly by hand, right? The model, the corridor model, is a tool in Civil 3D to produce the information you would actually show on a drawing. So nobody will ever see your model space nobody will ever see your corridor model unless they have your DWG, your drawing file, which I will check, right? I want to check that you're doing the design according to my instructions. But on paper, no one will know how you did it. You know, if you go to the grading plan, right, you may have calculated all these elevations one at a time with a calculator. You'd never know that, right? But the technique with the corridor model is much more superior, right? So how you do your work isn't necessarily anybody's business, but what you create is still stuff that we traditionally show. For the contours, did you want it to be in gray? Whatever I specified. I think I gave a layer color. You have to look at the assignment, module 3, the assignment. So I think I have layers here. I'm not sure. Did I say here what I wanted to do? Is there a surface? There's nothing in here about surface, paper space, underground. So there's some information here, all underground, not showing. Freeze the layer viewport, not in model space. That's the stuff I just talked about. Yeah, it should have, the grading plan should have existing ground contours. Yeah, and I would put them in now, but I think the specifications for that comes later. This drawing is not complete yet. So just show the contours, we'll add the labels and everything else later. So if I didn't ask you to do it on this assignment, don't worry about it. Okay, but I would show it. How do you want it to show in order to get full mark? The north arrow? It's got to be pointed in the right direction. So you have to make sure that the arrow is pointed in the right direction. The best way to do a north arrow is to click on the viewport, use the north arrow function, pick one. I like to use this one. Pick a spot, and there it is. If it's too small, click on it, grab the triangle, and you can make it bigger. So that should be pointing in true north because it's connected to the view. Yes, yeah, that's going to come later. We're not done yet, so don't worry about that. Right, all you're getting ready is this view. Make sure the grading view is ready to go. We're going through a procedure that's going to put you in a position to start lot grading design. That's the purpose of assignment 4. So right now we're getting ready for that. We're not designing anything yet. We're just modeling the corridor so we can get those front lot corners. We modeled the existing ground so we can get the back corner elevations. And then once you have a front and back condition, you can design what has to happen in between. And that's today's discussion. We're going to do some of that together. Okay, so if I didn't ask you for a legend, don't worry about it. It will show up in the final production. Assignment 4 will be a complete grading plan. Everything I want you to do for grading. Right now, we're just getting ready for it. So the first half of the course is really a lot of low order kind of drafting design and process and procedure. The actual engineering design takes place in assignment 4 and 5. That's where you design lot grading. That's real engineering work using these tools. And then in assignment 5, you're going to actually draw the plan profile of all the pipes. We're not going to design them hydraulically. So the size and slope will provide. You just have to draw it using these tools. Okay? So really the guts, the main focus of the course is going to be assignment 4 and 5. Everything else is kind of just getting ready for that. Okay, so if I asked you to do something, do it. If I didn't, you can leave it. Certainly specify it next time for sure. Okay, any questions about the layer control? Okay, and what's supposed to show on the drawing or not show on the drawing? And I think I was pretty specific here on the assignment handout. If you go to the end, here, it says, right, make sure all the underground information is not showing on the grading plan. Do show the existing ground contours, right? So that's an assignment there. The specification for that, if it's not here, just show it whatever you want. I think I asked you to create contours later at I think 1/4 meter and 1 meter, right? But I wasn't specific, so do whatever you like. Certainly show contours, not the 3D tin lines, right? And then on the grading plan, make sure there's nothing related to underground stuff. Nope. Sorry, I'll make sure all the grading information is not present on the plan profile. Okay, and again, the instruction is to freeze the layers through the model space, like I demonstrated. Okay, and this is the grading plan, the site grading or a grading plan. Okay, any questions about that? Can I go on? It's the last bit of news. Will you mark the previous? Well, you should only have one base plan, and it's just going to get more and more, detailed. You should only have 2 drawings. If you want to keep previous versions for yourself, that's fine. But sorry, will you mark? No. If the only thing you need to correct are the alignment and the edge of pavement. As long as you fix those 2 things, then you can continue. Anything else, if it's wrong, you can choose to fix it or not. It's up to you. Yeah. So I've already marked it. I'm not going to mark it again. So if you don't fix it, that's fine. Yeah, that's a good question. The only thing you need to fix is the stuff that I highlighted. Remember, the alignment must be correct. The edge of pavement must be correct. And if you've been working on it, you'll see why, right? The profile depends on it. The station values and profile depends on the key points in the plan at the edge of the pavement and so on. So those are the key things going forward. Okay? I will talk more about pipes when we do assignment 5. So there may be things you need to correct for the pipes that I already marked. I'll talk about that later when it's important. Okay, right now, don't worry about it. Okay, I can't, I wish I could teach you everything in one day and then mark it. I can't. I have to kind of just dish out a little bit at a time so that we head to a point where I cover everything. So what may not be required now will be required later, right? I just don't want to bombard you with too much. I'm trying to focus in on the purpose of each assignment to give you the skill sets you need going forward. By the end of the course, and I've said this before, I wish I could teach you this course after you take this course, because then you'll have it's kind of a silly statement, but when you have these skills, next semester is going to be a lot more fun. Once you have all these skills that you're going to get in this course, when you do MED, I can talk more about engineering design, and you'll already have the Civil 3D skills that you need to do that work. Okay, so it takes a little bit of time. So MED next semester is going to be very familiar. A lot of what we're doing here, you're going to do again. Subdivision's different. The topo's different. You need to create an alignment, lay everything in plan, design the profile, model the corridor, get your front lot corners, input the pipe design, and so on. It'll be the same process, just different starting conditions. Okay, so can I go on and do this grading exercise with you? I want to get started. Please have your calculators and a pen and a pencil or whatever you use to write with, and we're going to crunch out some numbers. And we're going to look at lot grading. First thing we need to do is establish some benchmark values, and then we'll talk about how to do the lot grading, how to actually design it, right? So first we're going to have a discussion of the standards, and then we'll have a discussion on how to do it. Okay. Now, if I don't get to how to do the grading today, we'll leave it for next time, after the break. But certainly I want to cover the theory today. So I'm going to share with you a file. Looks like this. This handout, it's online under module. Oops, I'm going to stop this. So this file, number 10 in the series, so this is the 10th in the series. So this is a handout that I normally hand out in class. We do this as a hard copy in class together. Okay, so can everybody see my my screen? It looks like a cross section of a house. Can you all see that? Okay. So here's what we're going to do. Let me just explain what this is, and then we'll start. I just want to make sure I've got some. I'm going to sketch all over this, but really we only need to type in. So the first thing you're going to notice is right here, this is the center line of the road. This is half a section. So there's the center of the road, there's the gutter, there's the street line. So we're only looking at half the section. Then what we look at is the front of the lot, where the road is, and the back at the limit of the subdivision. Okay, so that's the front, that's the back. So when you're at 3, you're going to have an elevation at the front, you're going to have an elevation at the front, and an elevation at the back. Okay. What you do in between is kind of spelled out in this cross section. Okay, so I'm going to assume an elevation here at the front. Let's say this is elevation 0. There are two different lot grading types. There's only two types. So here they are. I'm going to type in here. There are front draining, and there are split draining lots. Those are the two main categories of lot grading. They're the only two, front draining and split draining. What's the difference? In a front draining lot, when it rains, all the water that falls on the lot will eventually drain to the street, into the road gutter, into the catch basin, into the sewer. So that's a front draining lot. So the entire lot area, all the water that falls on the lot will drain to the front, to the road. A split draining lot is going to have a high point somewhere between the front and back. Let me draw a line here. So somewhere there's going to be a split point. There's going to be a split point, and some of the drainage will go to the backyard, and some of the drainage will go to the front yard. That's what we mean by split draining. Okay, so those are the only two grading types, front draining and split draining. In the category of split draining, there's three types. Okay, so it's either a front draining lot or a split draining lot, and if you're split draining, there's three categories of split draining. Okay, the split draining, and you have to understand a little bit about some house architecture. When it comes to split draining, there's three types. If the split point is in the middle of the lot, and part of the lot drains to the front and part of the lot drains to the back, this is part of assignment 4. This is grading. You're going to learn about this in MPT as well. So if it's a simple split, it means you have a gentle slope to the front and a gentle slope toward the back. Okay? Gentle slope to the front, gentle slope to the back. If the elevation at the front of the house and the back of the house are similar, are compatible, then we have a simple split draining lot. So this is called a simple split. And you still have some water going to the front, some water going to the back. When you start to get a differential, when the front yard is higher than the backyard, then you get into two more categories. So then there's what we call a back split, or sometimes referred to as a deck lot, or you get into what's called a walkout. A walkout. What's the difference? Okay. Well, I got to explain a little bit about architecture. When it comes to the elevation compatibility, if the front yard and the backyard elevation are similar, what happens is you can go a couple of steps into the front of the house onto the main floor, and then walk to the back of the house from inside, and then take a couple of steps down to the ground outside in the backyard. So they're very similar in elevation. When the backyard starts to get lower than the front, then you end up with what's called either a back split or a deck lot. And what that is according to the Ontario Building Code, if you have more than 3 steps out, you need a deck. And that's why it's also referred to as a deck lot. So as soon as you have 3 or more steps, you end up with what's called a back split or a deck lot. You have to put in a deck. You're not allowed to have 10 steps down to the ground from the door. You have to step out onto a deck, and then you have as many steps as you need. And that's why the term deck lot appears. So as soon as the backyard starts to get lower than the front, you end up with this differential in elevation. You end up with a back split. When the back split is extreme, when the elevation at the back is so low that you can actually step down onto the ground from the basement, then you have what's called a walkout. And that's the most extreme case. The walkout is you walk into the front of the building on the main floor, you go down some interior steps, and you walk out of the backyard. You walk into the backyard out of the basement, 1, maybe 2 steps down to the ground. That's what we call a walkout. It's the limit of a back split. You can't go any lower than that. You don't want to go down a flight of stairs from your basement. That's going to get ridiculous. So sometimes the house acts like a retaining wall. You go in the front door, compatible to the grade at the front of the house, and then you walk down the stairs to the basement, and you walk out of the basement. If you can walk out of the basement, it's called a walkout, and it's usually a step down. If the elevation at the back is higher than the basement, but lower than the first floor, then you're in that back split or deck lot situation. And if the front yard and backyard are compatible, then they call it a simple split. All 3 of these are categories of split draining lots. They all have a high point somewhere in the middle of the house. So the split point might be at the front of the house, draining to the front, to the back. It could be at the back of the house, draining to the front, to the back, or it could be anywhere in between, some to the front, some to the back. Remember, if it's a front draining lot, the highest point is at the back of the lot and it all drains to the front. So that's the difference. So it's either front or split. And if you're split, you could be a simple split, front and back compatible. You could be an extreme differential where you can walk out of the basement, or anything in between is called a back split. As soon as that requirement for a deck shows up, we call it a back split. As soon as the back split is low enough to walk out of the basement, we call it a walkout. Okay, so there's a range for the back split, there's a range for the simple split, but the walkout is the maximum that you can be different front to back. Okay, so there's a whole discussion about this these 4 categories. They call them 4 grading types. Really, there's only 2 drainage types, but they're 4 grading types. Right? Any questions so far? So front versus split draining, and then split, back, and walkout grading types for the split draining lot. So before we talk about how to do the design, how to do the lot grading, we need to look at the different categories in a little more detail mathematically. Okay, so if you can zoom in a little bit, might help. I'm going to consider, if I start at the front, and let's look at some standards. Let me actually bring up the standards. I'm going to share my screen. I'll show you where this is in the engineering standards. I want to go back to module 2 when I gave you the engineering standards. If you remember this, Town of Richmond Hill. Okay, can you see the Town of Richmond Hill standards? I hope. Can you see the standards? Give me a yes. Yeah. Okay. All right. So if we go to, I'm going to collapse all these. If I go to not sewers, not water main, not transportation, but grading. So here's the grading division. So this is about lot grading. It's worth reading this entire section just to prepare for next semester. Okay. And there's a similar one in the Town of Milton standards that we're going to use next year. So we want to look at minimum and maximum slope. We want to look at maximum transition sloping and so on. So if we go into here, there's a whole discussion on grading. So you can see here, the flattest slope allowed on lot grading is 2%. Right? So when rain falls, especially on grassed areas, you want it to be at least 2%. Anything flatter is going to cause ponding and wetness on the ground. You want to promote flow, so at least 2%. When it comes to maximum grade, 5%. They want you to be no steeper than 5%. 5%, when you look at it, is relatively steep, right? But I guess they've done the math, and what they want to make sure is that there's usable space, especially in the backyard, right? If you buy a house, you want to be able to use your backyard. And I'm talking about, residential houses, right? Single homes, semi-detached homes, townhouses. Development that has backyards, okay? Not condominiums. I'm not talking about commercial stuff like that. Okay, so just simple residential, single, semi-detached homes and townhouses. So the maximum slope is 5%, right? So 5% promotes better flow, but you don't want to be steeper than 5%. You want a generally, and 2 to 5% is generally flat, and you want an area, especially in the backyard of the house and certainly the front, that is relatively flat so that you can use the space. Okay, so there's minimum backyard space required, and basically what you're trying to do is make sure, when you put a picnic table in the backyard and you put down a bottle of beer or water or soda, it doesn't tip over, right? You want it to be relatively flat. You want to be able to use that space. Okay, so that's where that range comes from. Minimum slope for drainage, maximum slope of 5% for being able to use the space. Okay, so those are some key numbers. The next point there talks about maximum allowable slope. So if you have to transition between one elevation to another, then you want to use a maximum slope of 3 to 1, which is 33% if you convert that. 1 divided by 3 is 33%. And the purpose of a slope is to avoid using a wall, right? You'd rather not use a wall. So if you have space to put in a slope, you could rise or fall in elevation over a certain distance so that you can be compatible with a difference in elevation. That'll make more sense when we go into the calculations. If you can't use a slope to make up the difference, then the worst case scenario is a wall. Okay, and when it comes to grading design, a 4-letter word, the nasty 4-letter word, starts with a W, wall. Right? We don't want to avoid putting in a wall. The wall has a cost associated with it over time. It has maintenance issues associated with it. So if you can, you always want to avoid putting in the wall. Okay, but sometimes you can't avoid it. Okay, so those are some key numbers: 2%, 5%, and 3 to 1. All right, any questions about that? There's other stuff to read in here, and then you'll see the standards. Let me show you the standards for the different types, so you don't think I'm making this stuff up when it comes to the drawings. So it'll talk about, so this is a front draining lot. So this is the standard for a front draining lot. This is the standard for a split lot. This is the standard for a walkout or a back split. It shows them both, but they're two different types, right? So the terms are here. And this is a detailed grading plan of somebody's house lot. We're not going to design all the elevations. Let me zoom in here. See all the elevations inside the property? Okay, that's detail that typically is provided by an architect. What we're going to do is design the elevation at the back, the elevation at the front of the lot, elevation at the back. See if I can highlight this. Elevation at the back. Can you see my cursor when I move around? Can you see my cursor? Oh, okay, good. So this is the elevation at the back. Shoot. Okay, this is the elevation at the back. This is the elevation at the back. This is the elevation at the front lot corner. This is the elevation at the front lot corner. So at the end of assignment 3, you're going to have elevation at the front of each corner and at the back of each corner. Okay, and then what we do in between the front and back is our responsibility. Okay, what happens inside the lot, all the proposed corners of the house and so on, that's usually the architect. We would review and certify that, but we wouldn't design it. We're only designing the perimeter along the lot line, at the front, at the back, and along the sides. Okay, so that's our only responsibility. Okay, so this is worth reading. You may want to look at this through the break, if not sooner. I know you're concentrating. There's an assignment due Friday, but you want to start. I don't want to waste the week next week. So if you have time, you can start looking at this. Okay, so this is where I'm getting today's lecture from, the grading. And it's worth reading the words, right, where it starts. It's worth reading, where did I have it here? Sorry. Grading. It's worth reading the first few pages when it talks about lot grading. Right, minimum, maximum slope, swales, all this kind of stuff, driveway, transition slopes, and so on. Retaining walls, talks about retaining walls, catch basins, fencing, and so on. So this is worth a read. It's only about 5 pages, 6 pages. I would read these 5 or 6 pages and look at the standards. My design that we're going to go through together is a slight modification based on my experience. What I know has been previously approved in Richmond Hill. That's where most of my work experience has been when I was in industry. So I know something a little more practical than just what's in their standards, stuff I know that's acceptable. Okay, so back to the PDF. So let's go back to share, share that cross section. So back to this. Okay, so everybody see the section again? The house section. Can you see the house section? Okay, so what we want to do now is pick up a few key things. From your drawing, you're going to be able to figure out what's called the lot depth. Okay, so the lot depth is this from the back, from the front of the house to the back of the house. So we're looking at this distance here. This distance here. So to figure out this number here, the lot depth, you simply go to the AutoCAD drawing and list the line between units. So I'm just going to tell you what I'm going to use for today's calculation, but certainly you want to get that. So that's where this number comes from. What's the distance from the corner at the front to the corner at the back, which is just the length of the side of the lot. Okay, so we're designing between houses. So I'm going to tell you today that's going to be, let's see if I could type it in here. The lot depth here is actually going to be 32.7 meters. Okay, so if you had a piece of paper, you'd be writing it in. So I'm just going to type it on screen. So that's the depth of the lot, 32. Then you can't build a house right at the street line. So you have to have what's called a front setback. So the front setback is typically, there's a range, but what I want you to use is going to be right here. I want you to use 8 meters. Okay. Now, the house might be closer to the front. Sorry, 32.7, my mistake. I said one thing and my typing did something else. Sorry. Thanks, Sumitra. So it's 32.7 meters deep. The front setback to the building is 8 meters. Now, the building itself might be closer to the right-of-way, but not much closer. What I want to make sure is I'm at least at the front of the building. Doesn't matter. We're designing from one corner at the front to the corner at the back. Okay? We're not designing the middle. We're designing the sides, the edges. Okay? So the length along the lot line. So in AutoCAD, there's lines between the lots. If you list it, it tells you how long it is. That's where the 32.7 comes from. I'll demonstrate all that, right? Forget about AutoCAD for a minute, right? Let's just get through this exercise. So 32.7 comes from the drawing. I'll demonstrate where that comes from. 8 meters, because I said so. That's a number that seems to work. Sometimes it could be as low as 6. Sometimes it might be 10 meters, but you need a little bit of a setback. The zoning will tell you how close the building can be to the front of the lot, but then we usually push the split point. What I'm trying to establish is if the front of the building is here, then the split point at the front is covered. If the building's a little further forward, that's fine. The front yard must drain away from the building. You can't have water from the street line draining toward the building. Okay, that's not allowed. So if you want to see this, there's no such thing. You can't drain from here toward the building. It always has to be higher at the house than the street line. Your front lawn drains to the street. Always. Doesn't matter what type of drainage you have. Okay? Everything drains to the front from the front of the house. So that's not allowed. The backyard could go either way. Okay, so 8 meters. A typical house depth, and again, it depends on the architecture and the depth of the lot. You can't see my, you can see my cursor when I'm circling? Can you see it circling? No, okay. Oh, you can't see, sorry. All right, so I'm just gonna keep typing. Hang on a second. So let me draw that line, right? So from the front of the lot, you can't drain toward the house. Do you see that red line? That's not allowed. Has to drain away from the building. Your front lawn always falls toward the road. Okay, let me get rid of that. So the next thing we want to look at is the house depth. So I'm going to give you the house depth. Again, there's ranges, but for this exercise, I'm going to use 12 meters. Okay, so 12 meters is the depth. The front of the building to the back of the building is the house depth. So when you're doing your lot grading, assignment number 4, 8 meters is given, use 8 meters. 12 meters, that's given, you use 12 meters. 32.7, that's going to vary. Every lot line is a little bit different. So you have to list each one and design each one separately. Okay, so that number varies. This number down here, this number varies. You design from the front to the back on one line. Do what you have to do, and that's what I'm getting to today. And when that's done, you go to the next lot line. What's the front? What's the back? What are you going to do in between? Then you go to the next line. What's the front? What's the back? What do you do in between? And if you haven't figured it out yet, there's about 35 lots. You have to do this 35 times. There's a lot of work to do, but it's very repetitive. So I said at the beginning of the course, if you remember, the only thing, all the tools and skills I'm going to show you and that you're going to practice, the lot grading tools and lot grading design is the one thing you're very proficient at, because you have to do the entire subdivision. So there's a lot of work to do, but it's very repetitive. Okay, so if you haven't figured it out by now, you see the volume of work. You have to do this analysis and design for each lot line, and there's about 35 lots. And if that doesn't scare you, next semester there's over 50 lots. But again, same skills. Okay, so let's finish the discussion. Another thing you need is minimum backyard. So this is the space. Excuse me. This is the space where you're going to put your picnic. You want to make sure you have at least a usable backyard. The depth for that typically is 7.5 meter minimum. Okay, that's minimum. So 8 meters the front, 12 meters for the house, 7.5 minimum usable backyard. Those three numbers are fixed. Everyone's going to use those three numbers. Again, the only thing that's going to change is the minimum lot depth, or the lot depth, right? So if your lot depth was 32.7 and you had 8 meters at the front, 12 meters for the house, and 7.5 meters at the back, what do you have left over for sloping? What's this number? What's the horizontal distance from the minimum usable backyard to the back of the lot? Anybody confirm that? Very good. Yeah, that's exactly what it is. So 5.2. So you got to do the math. Every time the lot depth, 32.7, changes, you have to redo the calculation and put in a new number back here. So this will vary. Okay, so again, I'm going to draw a box around it. This varies. This will vary depending on this. Every time the depth of the lot changes, the minimum, the additional lot depth changes. 8, 12, 7.5 is fixed. That never changes. Okay, for this class. In reality, there are different values, right? But I got to give you something to start with. Otherwise, it's not going to be meaningful. Any questions so far? Yeah, go ahead. Any questions so far? Do we have to manually solve for each in the drawing? Yes, you do. You can't see me, but I'm winking. Yes, you do. We're going to do it together once, and then I'll give you a tool that helps you with it. Okay, I want you to understand the theory. So we're going to crunch these numbers together. We're going to do one together in class, and then I'll give you a tool for helping later. When you're talking about the depth, is it the horizontal distance? Yes, yeah. When I mean depth, I mean horizontal distance, right? How far away from the front are you or from the back? Horizontal, yeah, that's a good question. Okay, so I'm going to come back to this. I need to discuss, remember the standard? What was the minimum slope? Usable space. What's the minimum slope? To what? I'm being picky now. To what? 2%. Very good. What's the maximum usable slope? 5%. Very good. Do you see 5% anywhere on my drawing? You see do you see 2% and 3%? Positive, negative? Does anybody see 5%? No. Okay. There's a reason for that. The maximum allowable slope is 5%. If you use 5% to design your side yard, right, the side of the lot, the edge of the lot, the side yard, you're going to cause problems internal to the property. Okay, and we're going to do some math together. I'm going to show you exactly why. I'm going to do a sketch off to the side here. I'm going to zoom down near the bottom, bottom left. I'm going to draw a house, and I'm going to draw a lot and a house. So here. Here's the lot. This is the plan view, and then I'm going to draw a house. I'm going to draw a house. So here's a house. Okay, so then these distances, right? The distance from here to here is 8 meters. The distance from here to here is 12 meters. The distance from here to here is 7.5 meters or more. Okay, everybody with me? Okay, so this is the plan view. Okay, I'm going to zoom in on that corner. Okay, so if you have control of the zoom, so it's up to you. If you want to zoom in on that corner, you have control of how much you zoom into this. So I'm going to use some hard numbers to do this calculation. Okay, I'm going to start at so I'm going to assume that the front is down at the bottom right. So I'm going to put in a number here. I'm going to put in a number here, 100. That's the elevation of the front lot corner right here. Okay. Now the drawing is exaggerated a little bit. The distance from the front of the lot to the front of the building is 8 meters, right? So let's put that in. This is 8 meters. Going from here to here. This is 8 meters. The typical setback in the side here, this side yard, typically is 0.6 or 1.2, right? 0.6 or 1.2, either 2 or 4 feet, okay? It's relatively short compared to 8 meters. So keep that in mind. We're going to do a very crude calculation. If I want to know the elevation of the corner of the building here, I need to do two things. I need to come up from the front and calculate the elevation opposite that point on the lot line, okay? Let's assume that's going to be 5%, the maximum allowed, okay? So if the elevation here is 100, and what's the elevation here going to be if we're going up at 5%, right? We want to drain down, so this is higher. What's the slope here? Or sorry, not the slope, what's the elevation here? At the lot line opposite the corner of the house. We're going up, yeah, 100.400. That's the elevation of the lot line opposite the corner of the house. Now, when you look at a cross section, of a lot, what you'll see is, I'm just going to draw 1/2. I'm going to look at this section. You see the wall of the house. You see, so that's the house wall. And then you see the property line. And whatever the elevation is, opposite the corner, the elevation at the house is going to be higher by about 0.15 meters. So that the other house, there'll be another house next to it, you would go up to that one as well. And this height is at least 6 inches or 1.5 meters or 15 centimeters. And then you're creating a swale, like a ditch between the houses. So if the elevation here is 100.4, what's the elevation here going to be? $100.55. Okay, so everybody with me so far? So we have to slope up toward the building, and I'm using the maximum, 5%. Once I have the elevation on the side, on the lot line, then I think what's going to happen at the house? The house has to be at least 6 inches higher or 0.15 higher so that we have flow away from the building to the lot line on both sides, and we create that V-shaped ditch or swale, okay? If now we consider this line here, this red line, from the corner of the building to the front corner of the lot. I'm going to assume, because the width is so small, that the length of this red line is about 8 meters. Everybody agree? It's going to be very close to 8 meters. Okay, I'm stretching it a little bit, but it's going to be very close to 8 meters. So now let's do the math. What's the slope of the red line? Well, I know the elevation here. The difference is the rise. Divide by 8 meters, the run. What's the slope of this red line? Anybody? What's the slope of the red line? Yes, greater than 5%. Okay, it's going to be 6 point something, which means that's also happening on the other side. So the entire front yard is steeper than 5%, and that's not allowed, right? The maximum slope for a usable space is 5%. So if I use 5% to do my work, there's no way that the architect can achieve maximum 5% inside the lot. Okay, that's my point here. So if the architect wants to use maximum 5%, I have to use something flatter to get the elevation opposite the corner of the house along the side of the lot. So let's reverse engineer it. What if we go from 100 up to the house at 5%? So instead of using 55, I'm going to use 0.4 over here. 100.400. That's 5% up from the corner of the lot at the front to the corner of the house. Then I'm going to come down, right? I've just designed this elevation here. Look at the cross section. I've got this elevation here now. What's the elevation in at the opposite the corner on the lot line? What's this elevation going to be? If I come from the front to the corner of the house at 5%, I'm going to go down this much. What's the elevation on the side of the house in the lot corner? Yeah, I'm going to subtract 15. So this elevation becomes 100.250. Everybody with me? So now if I take, what's the slope from this point to the front? But 3%. I limit myself to do at about 3% max, then that almost guarantees that the architect will be able to achieve maximum 5%. Does everybody understand this discussion? If you don't understand this, you don't have any idea why I'm not using 5. Okay? This is the reason why I'm not using 5. So when we go back to my sketch, you'll see 2 minimum, 3 maximum. And the reason I'm using 3 and not 5 is because I'm worried about what's going to happen inside the lot when the architect designs the actual space of the lot, not the sides, which is all I'm responsible for as the civil designer. Any questions about that? Does anybody not understand that exercise? Okay, so that's why, even though the standard says 5%, they mean 5% anywhere. Well, if you want to have maximum 5 inside the lot, you can't use 5% on the edge, and this is why. And that's true in the backyard as well. The same idea is present in the backyard. Okay, so that's just a brief explanation as to why I'm not using 5%. If we go back to my drawing, if you zoom out and look at the entire cross section that I'm working on, I have 2, 3 maximum, 2 and 3 maximum for my usable softer, flatter slopes. Okay, so that's why you don't see 5% on any of the analysis we're about to do. Any questions about that before we go on? Okay, that's worth noting. You want to be a rock star at work and you start doing lot grading, make sure you don't use 5% along the side yard. Okay, it happened to me once. I thought I could get away with it, but it's as soon as they see 5% on the grading plan, they know the architect's not going to work. Their work's not going to work out, and then it causes problems. So you have to have a little bit of knowledge as to what your information is going to be used for later, and that's why I'm telling you this. So the standard says one thing, in practice we have to do something a little bit different. Okay, can I go on? Any questions? All right, so now what we want to do is establish for the different categories of lot grading what the elevation difference is going to be between the front of the house, the lot corner, so this point here. I have an elevation at the front, and I'm going to assume it's 0 so that I can do some easy calculations. I'm going to assume it's 0. I want to know the elevation at the back in various grading scenarios. Okay, so we're going to do a whole bunch together. Okay, so you're going to need your calculators. Like I said, I want everybody to crunch the numbers. And this exercise is worth doing at least once so that you can practice. Okay, let's deal with the front drainer. Suppose the elevation at the back of the lot is much, much higher than the front. Okay, there's your front draining lot. Okay, so there are 3 categories of front draining lots shown here. There is a minimum backyard. So you start at instead of starting at 2%, I'm trying to go as high as possible at the back. So instead of using 2%, I'm going to use 3%, right? So I'm going to use this one, not this one. So I want to start off a little bit steeper so that I can start to come up faster. Okay, so I'm going to use 3%. If I want to maximize how high I can be at the back, I'm going to use 3%. So 3% for the front yard, 3% all the way to the back of the building, and 3% all the way to this point here. The minimum point where the minimum backyard is achieved. So what's the elevation of that point there? So if I come up 3% all the way to the minimum usable backyard point, what's the elevation here? So you take the total distance, 8 plus 12 plus 7.5, multiply by 3% and add it to 0. And what do you get? 8 plus 12 plus 7.5 equals times 0.03, 0.825, 0.825. Okay? Anybody not clear where that number comes from? Okay, and just to be more specific, I would do this. I would do this. I would put a plus sign. It's higher than the front, right? So it's positive. It's a plus, higher than the front. Remember your ordinances? Is it higher or lower, relatively speaking? Remember highways, ordinance, H1, H2? This is going to be plus, higher than the front. So that's as high as I can go, all the way to the minimum usable backyard. Beyond that, if I have more lot depth, right, I then can use a 3-to-1 slope. The 3-to-1 slope then allows you to rise faster for this extra space that you have, so that you can avoid building a wall. So 3-to-1 is actually 33%. What's the elevation at the back of the lot? This number here. Remember, we started at 0, we came up 825, and now I want to go up to the back, starting from this point here, the usable backyard. What's the elevation at the back? Okay, and 2 decimal places. Doesn't have to be that accurate. 2 decimal places is plenty. Actually, I'm going to change. I'll change that. But right at the end, the last thing is 2 decimal places. Yeah, so that's exactly what I would do. So back here, I would have a positive 2.56. Okay. So you start at the front of the lot. You go steep, 3%. Stay away from 5. All the way to the point where the minimum usable backyard is defined. And then from there, that extra depth, that additional lot depth of 5.2 meters, we're going to go up all the way to the back of the lot. So if the backyard elevation is higher than the front elevation, and it's more than 2.5 meters higher, then we're going to need a wall. So imagine the difference. You know the drawing you're preparing for Friday? If you have an elevation at the front and you have an elevation at the back, say your existing ground is up here somewhere, then the way you're going to design it is you're going to go from the front to this point here, up at 3%. Then from there, you're going to go to the back, up 3-to-1. And then to make up the difference, that's as high as you can go before you need to put in a wall. You're going to need a wall here to get up to the existing ground. If the existing ground at the back is higher than 2.56 than the front, this is the best you can do. And if you use that 3-to-1, you minimize the height of the wall, right? If you don't want to use if you want all usable backyard, then your wall extends all the way down to here. And that's much higher, much more expensive, and so on. So we use the 3-to-1 slope to minimize the height of the wall. So first we try and avoid it. If you can't, you try and minimize it at the very least. Okay? So that's a number, a threshold you want to know, right? So what are we looking for? Let me delete some of these things I drew. And you don't need this number anymore either. All you need is the elevation difference between front and back. So let's describe this one more time before we go on. If you know the elevation at the front and you know the elevation at the back, the difference, which is what this number represents, the difference tells you what kind of design you need to perform. So if the elevation at the back was 3 meters higher than the front, then you would design it like this. Go up at 3% to this point here, go up at 3-to-1, and then the difference between this elevation and your existing ground elevation at the back, the difference would be the height of the wall. Okay, any questions about that? Now, that's not always going to be the case. There's other categories. So let's look at a couple of other examples. We're going to look at all these examples. Suppose you want to have all usable backyard space. So if you start with an elevation of 0 at the front, go all the way to the back of the lot as steep as possible. So in this case, 3%. Remember 105. What would the elevation at the back be if I want all usable backyard? Yeah, that's exactly what I get. So what would it be? It would be, I'm going to put it on the drawings a second. I'm going to put it here. It would be positive 0.98 meters. Okay. So if the backyard was about a meter higher than the front, you'd have a front draining lot where the entire backyard is usable. It's 3%, maximum 5% internally. And that's great. That'd be good if I could use the entire backyard. But again, it depends on where the existing ground is. So if the existing ground, let me walk you through this again. If the existing ground is way up here, you're going to need to go minimum usable backyard, 3-to-1 slope, and then a wall. If the elevation at the back is in here somewhere, right? Let's say it's exactly here, then you have a full 3% lot. If you're between these two numbers, then what I would do is I would start at the front and go up at 3%, and start at the back and go down 3-to-1. And then I'd have a little extra usable backyard. In fact, any number between 256 and 98 would have that solution. So let me draw that one more time. If the difference between the front and the back were between the two numbers we just calculated, 256 and 0.98, right? Suppose the difference was 1.6. Suppose your existing ground was here, 1.6, somewhere in here. Then I would start at the back and come down at 3-to-1, right? Parallel to this. I would start at the front and come up at 3%, and I would find this solution. Then I would have this much extra usable backyard. Okay? And that's the way you would design it. I'll show you how to do that, right? You just have to understand that's what you need to do. Okay? Suppose we don't need 3%. Let's use the minimum. Instead of, let's use 2%. Start at the front and go all the way to the back at 2%. That's the next scenario. So then you would be about 0.65 above. I want to make sure that's a little bit higher. It might be confusing. Put it up here. Okay. So if you come up at 3%, you're 0.98 above the front. If you come up at 2%, you're 0.65 above. Anything in between would be a split drainer, right? If you're, let's say it's 0.75. Let's say the difference between the front and the back were 0.75. You'd be between 98 and 65, which means your front drainer would be 2-point-something%, steeper than the minimum and flatter than the maximum. So any difference between 2 and 3%, or 0.65 and 0.98, any difference between the front elevation and the back elevation, between 65 and 98, would be a front draining lot with all usable backyard with a minimum slope of 2, maximum 3%, somewhere between 2 and 3. Everybody understand that? Okay. Now we're starting to get lower and lower, right? We started way high and we're starting to come further and further down. We're starting to be compatible with the front and the back. So now instead of 3%, at the front, we're going to use the minimum 2%. So for the rest of the scenarios, we're going to use 2%. There's a couple of options for the next scenario. Now we get into the split draining lots. So the first thing I want to consider is, what if the split point was at the back of the building, right? So I'm going to start at the front of the lot. I'm going to go up at 2% all the way to the back of the building. And then from there, I'm going to go down 2% to the back of the lot. What would the elevation here be at the back? Come up at 2% from the front of the lot to the back of the building. And then from there, go down 2%. Anybody else? Okay, Daniel and Claire, I think you're off there. Let's do it again. If you have to do the calculation in two parts, you can. So what's the elevation at the back of the building? So the elevation here is going to be 20 times 0.02 is 0.4, 0.40, positive. So that's the elevation at the back. And then from there, we're going to come down at 2%. So 0.4 subtract 12.7 times 0.02. We're going to be, and Trung and Carl, is that going to be positive or negative? Are you still higher or lower than the front? Plus 0.15. Yeah, it's going to be higher, but not by much. It's going to be very, very similar, almost the same. And so that's this one here. Okay, so this is just an intermediate step, 0.4. So you come up at up 2% and then down 2%. So the final thing at the back is all we're interested in, positive. So if the backyard and the front yard are compatible, they're almost the same, right? The backyard's a little bit higher, but not much. You would have a split point. You would have a split point right there. So the side between the houses would drain to the front, and then the front yard always drains to the front, but the entire backyard drains the other way. That's one scenario. What if the split point was at the front of the building and we'd be coming down at not 2%, but 3%? What would the elevation here be? It would be lower than the front for the first time. Anybody else? So I get negative 0.58. So the elevation at the back of the lot is about 2 feet or 0.58 lower. So start at the front, 0 elevation. Start at the front, 0. Go 8 meters for 2%, whatever that number is, and then subtract 3% of 12 plus 7.5 plus 5.2. Right? So 8% of 2, or sorry, 2% of 8 gives you the elevation at the front of the building. And then from the front of the building, you're going to go all the way down to the backyard, 3%. So 12 plus 7.5 plus 5.2. Yeah, exactly. Okay. So there we are. So now between 0.15 positive, right? I'm gonna do this. In these two numbers, between these two numbers, if you're 0.15 higher at the back, you have a simple split where the split point is at the back of the building. Right? The split point would be here. If you're negative 0.58 lower at the back, your split point would be at the front of the building. Okay? If you have a difference between front and back between those two numbers, positive 1.5 and negative 5.8, if you were in between, then you would come up from the front at 2% and come up from the back either at 2 or 3%. One of them is going to work, and you're going to end up with a split point somewhere between the front and back of building. Okay? The split point has to be between the front and the back of the building if you're in a split draining situation. Front drainer is the exception, obviously. So if you're between positive 1.5 and negative 5.8, you're going to have a simple split where the split point is either going to be at the front, at the back, or somewhere in between the building, front and back. All right, so that's the scenario there. So I'm just going to tidy up the drawing. Okay, I need to draw and point to what I'm saying, otherwise it's not going to make sense. Okay. So now we start getting into the other stuff, the differentials, the back split and the walkouts. Let's deal with the walkout first. So a walkout is generally defined by 2.1 meters straight down. So if the elevation at the front of the building versus the elevation at the back of the building had a vertical difference of 2.1, That'll be the maximum. That's compatible. That almost guarantees that the first floor is above the front of the front lot elevation, and the back of the building is just below the basement elevation. So that gives you your full walkout. So 2.1 is kind of the magic number. We can create an Excel sheet. I'm going to give you one, Daniel. So if you're pulling your hair out, just be patient. Okay, I need to teach the theory, and then I'll give you a tool to help you with this. Okay, a little bit of patience. Let's go through the theory, and then I'll give you a tool. Okay. You have to do this once, otherwise you won't understand what the spreadsheet does for you. Okay, I'm sure you're starting to figure it out, but it's important. So if the elevation at the front is 0, the elevation at the front of the building is 8 meters up at 2%. So I want you to come up 2% to the front of the building, then subtract 2.1 to get the elevation at the back of the building. So what would that number be? What's the elevation here at the back of the building? Anybody? Negative. Yeah, it's going to be negative 194. So from the front of the lot, you're going to be almost 2 meters below at the back of the house. Then from there, I want a full usable backyard. So go down to the back at 3%. And what number do we get there? Negative 2.32. Very good. So that would be the elevation. So what does that represent? That represents a full walkout house with a full usable backyard. Everybody agree? So if you were going to walk through if you were going to walk from the front of the lot to the back of the lot through the house, you would walk up the front lawn, take a couple of steps into the first floor, go down the staircase to the basement, walk to the back of the house, step down onto the ground, maybe 1, maximum 2 steps, and then you could walk all the way to the back of the property. Nice slope of 3%. Full usable backyard. Now again, if the backyard is much lower than the front yard, then we can start introducing that 3-to-1 slope, but down instead of up. So what would the usable backyard elevation point be here? What's this elevation? Let me do this. What would the elevation here be? That last red dot I drew. Yeah. So that elevation here is going to be negative 2.165. And then what would the elevation at the back of the lot be if we were going to maximize the 3-to-1 slope? You know, two decimal places. Negative 3 point, I get 89.9 is correct, okay? So if the elevation, this is kind of the opposite scenario now. If the existing ground, what if the existing ground was way down here? Then I would design this. I would start at the front, go up at 2% to the front of the building. Then I would lower the backyard by 2.1 meters to get the elevation at the back of the building. Then I would have the minimum usable backyard. And then I would come down at 3-to-1. And then the difference would be a wall. I'd have to put a wall here to make up the difference. So when you measure the difference, what's the elevation at the front? What's the elevation at the back? When you know the difference in elevation, if it's lower at the back by more than 3.89 meters, you know you're going to have a full walkout, a minimum usable backyard, a full slope, and then a wall to make up the difference. Okay, so these are the different grading scenarios you're going to run into. Some people will practice some. There's only 4 types. Oh shoot, I didn't mean to do that. Push the wrong button. Anyway, so those are going to be let me put the numbers back in. I'm sorry. Still getting used to this. 8.0, 12.0, 7.5. I apologize. 5.2. We started with 32.7. And then let me just put these numbers in very quickly. positive 2.56, positive 0.98, positive 0.65, positive 0.15, negative 3.89, negative 0.39, and then we did the 5.8 here, positive negative 0.58. Sorry, that's where we're so far. So again, if these are different thresholds. Now this one in the middle, the one I skipped, is just where the back split starts. So generally speaking, I usually ignore this, but it's worth noting. Usually if the front and the back have a vertical difference of about 4 feet or 1.2 meters, then you'll end up with a back split or a walkout. So this is a simple split. This is a simple split. Anything between here and here is going to be a simple split. As soon as you get below that threshold, you're getting into back split territory, this area here. And then as soon as you get to the maximum difference, that's the walkout. So the walkout is only one condition. Any difference in elevation between these two lines is going to be a back split. Any difference in elevation between this line and this line is going to be a simple split. Okay, but this is the threshold where the deck shows up. I usually ignore this. It really doesn't matter. I don't have to look at it, but it might be worth noting. Okay, so let's just do that. It doesn't change your design. It just changes what you call it. Okay, but the design will be exactly the same. So let's clean this up. So what would the back split scenario be? What's the elevation at the back going to be? Let me move these up so they make more sense. And then the full walkout, I think I gave you this one too, right? We did this with a full usable backyard. Negative 2.3. So what would this one be? What's this one going to be? Oh, sorry, I think I gave it away. Yeah. $256, 98, 65, 15, 58, 389. Okay, I missed something. 98, 65, 15, 58, 232. Yeah, so then the walkout would be, yeah, I think that's right. Somebody confirm that? Negative 1.42. Sorry. Yeah, negative 1.42. Sorry, this is wrong too. Let's type this. This should be 389, not 3.39. Negative 3.89 at the bottom. Sorry. So again, if you calculate, start at 0, go up at 2% for 8 meters, go vertically to the back by 1.2, and then go all the way to the back at 3%. You should be 142 below the front, negative 142. So these are the thresholds. These numbers, you need to know what these numbers are, because what you're going to do after assignment 3 is you're going to go to each lot line and measure the vertical difference between the front and the back. And then you'll fall somewhere between all of these numbers. You could be higher than 2.56, then you know you have a front draining lot with a full slope and a little bit of a wall. You could be lower at the back by more than 4 meters, and then you know you have a full walkout with a minimum usable backyard, a full 3-to-1 slope, and then a retaining wall. Or you could be somewhere in between as a scenario. Okay, so these numbers at the back that I've shown and we calculated, they're going to guide you in terms of what your design is going to be. So you can describe the design based on what you see here, right? So if you're between, let's say your existing ground, and I'll just describe a couple here. Suppose your existing ground elevation. If your existing ground elevation, let's say your existing ground elevation was in here. Suppose your existing ground was between negative 232 and positive 389. Then what I would do is I would do a full walkout. So I would design the elevation at the front, the elevation at the back is a full walkout. And then I would come down at 3% and I would come up at 3 to 1 from this backyard elevation. See existing, I would come up at 3 to 1 and I'd have a little extra usable backyard. Right? That's a bad drawing, should be parallel, but that's what I would do. Okay, so we can talk about what the design should be, right? I would come up parallel to this line here at 3 to 1, and there's my backyard point. So now I have not minimum 7.5, but a little extra usable backyard. Right? If I was between here and here, if I was in here, I would just come up at 3% to the building, and that would be it. I'd be done. And then if I wanted to design these 2 points, I could come down at 3% and up at 3 to 1. Right? If I came up between, I would come down at 3% and up at 3 to 1, and so on. So how to design those things, I'm going to show you. Okay, but these numbers are what guides you. Okay, so this is something that's very important. Civil 3D doesn't design anything. You're the designer. The analysis we just went through together is going to guide you. It's going to kind of prompt you into what the design should be. All Civil 3D does is input the design, your design intent, accurately and quickly. So it's a tool. It doesn't design anything. You do. You're the designer. Okay. What you have to keep in mind is that when you're inputting information into Civil 3D, you're telling it what you want because you already know what you want. Okay. It doesn't design anything for you. You're the designer. If the rear lot elevation is below 3.9, then you'd have a wall. Yeah, exactly. So then you would come up. Let me do this in a different color. I would start at the front. I would go up to the front of the building. Then I'd take that elevation, lower it by 2.1. Then I would go down at 3% from the back of the building, down at 3 to 1 to the back of the lot, and then I would provide a wall to get down to whatever elevation you have to. Anything, it's going to be lower than 389. Yeah. Okay. How you put this into AutoCAD Civil 3D, I'm going to teach you. Okay. But what you put in is determined when you look at this. As soon as you get all those numbers at the back, it'll put you into a category of what to do. Okay. So please don't think that Civil 3D designs for you, right? It helps you input the design. What you're going to design is based on the analysis here. So for every front and lot corner, let me go back to Civil 3D. Let me do this. I'm trying to intimidate you because there is a lot of work to do. I'm going to go back to this model. Okay, remember this? So for every lot line, right? Here's a lot line. If I list it, it tells me the length. That's the number you put in at the bottom. Remember our 32.7? Okay, our 32.7, sorry. Sorry, I'm not sharing. Thank you, Daniel. Share, entire screen, allow. Okay, so let's go back to my drawing. Remember this drawing, right? Let me get rid of the surface, just so it's in the way. No display. Okay, so at the end of assignment number 3, which you're working on now, you should have all these numbers. An elevation at the front from the corridor model, an elevation at the back from the existing ground surface model, right? So with that analysis, you're going to look at each lot line. What's the length of this line? 3593. What's the length of this line? 37.4. What's the length of this line? 42.9. What's the length of this line? 42.9. What's the length of this line? 33.5. What's the length of the next line? 33.5. Those are the numbers for the total depth of lot. And the example I was doing, 32.7. That's where the 32.7 comes from. What's the length? The distance from front to back. So you just list the lot line that tells you how long it is. Then you look at the elevation difference between this point and this point. Okay, now I've blocked it out, but I can still do this. If I turn my OSNAP to node, I can measure the distance, DI for distance. I can snap to the node at the front, I can snap to the node at the back, and it'll tell you the delta Z. So the elevation difference here is 6 meters. So what am I going to design? A full walkout with a minimum backyard, and there's still going to be a wall at the end, a couple of meters high. Everybody understand what I just said and why I said it? So you have to design each one. Then I'm going to go to the next one. So I'm going to design this one. I'll input all those numbers. Every time there's a change in slope, I need an elevation. So if you go back to that drawing, let me see if I can find it here very quickly. If I go back to module 4, whoops, upload. If I go back to this section, if I know I'm going to design a full walkout in the plan view, right? I have an elevation at the front, an elevation at the back. It's way down here. I need to put in between 1, 2, 3, and then between the front and back of building 4. So 1, 2, 3, 4 elevations between the front and the back. And then an elevation here, and then my existing ground is going to be lower. So 1, 2, 3, 4, 5 numbers need to show up between the front and the back. Okay, so for that one there's going to be a number at the front of the house, a number at the back of the house. And let me just show you some offsets. Offset 8 meters from the front. That's where the building starts. 12 meters. Offset 12 meters. There's the back of the house. Offset 7.5 meters. There's your usable backyard. And if you need it, this will all be 3-to-1 sloping. Right? So you're going to need come up at 2%, take that number, bring it to the back, push it down 2.1 meters, go down 3%, go down 3-to-1, and then whatever you propose at the back, it's going to be still higher than the existing. That's the difference. The difference will be the height of the wall. So I'm just trying to give you an idea of what happened between 2 rear lot lines. What happens between 2 rear lot lines? I'm not sure I know what you mean, Tron. 2 rear lot lines. You have an example? Do you got points, 2 rear lot lines? Oh, between these two? What happens between these two numbers? Nothing. Just leave it alone. We're only designing what happens between the front and the back. And what happens between the front and the back. And what happens between the front and the back. Every pair of front back, every lot line needs to be designed. You do nothing in between. Between here and here, you do nothing. Between here and here, you do nothing. You design each side, each side, each side, each side. Okay, so there's a lot of work to do. Lots of work to do. There's a few things that are a little bit tricky, but for the most part, after assignment 3, if you have a front, you have a back, you can design. If you have a front and you have a back, you can design in between. It gets tricky in here. Let me show you this. And I will discuss this in detail, but I'm not going to do it now. What do you do here? What's the backyard elevation here? I'm not going to tell you. I'll tell you when we get back from the break. But how do you deal with that? I'll explain that later. That's a little more tricky. But if you have a front and back, you can design in between. If you have a front and you have a back, you can design in between. If you have a front, you need a back before you can design what's in between, and so on. Okay, so we'll get to that. But for the most part, except for areas like this, it's very heavy. There's a lot of work to do, but it's very repetitive. So yes, I'm glad you recognize that. I've said it a few times, but I think now that I showed you all these lot lines, you see that there's a lot of work to do. Should we put rear lot elevations at 4.5 in assignment 3? Here? No, no, that's done differently. Just leave it blank. I'll explain how to do it after the break. Okay. All right, so that's the, I don't want to show this. That is the design discussion. This is a topic that you're probably going to cover in MPT with Professor Neruzzi. He'll talk about lot grading as well. I teach it because I know exactly what I need you to know about lot grading so that I can teach you the tools to do it in Civil 3D. So I cover it again. It's very specific to using Civil 3D in this course, but a general discussion about lot grading will also take place in MPT. Have you done that yet? Usually I know he covers it. Have you talked about lot grading yet in MPT? We're doing lot grading. Oh, good. Okay, so this should be familiar. Okay, I'm giving you like just exactly what you need to know for this course. He's going to give you a more general discussion. Okay, mine is pretty detailed because I know specifically what you need to understand to do my assignment. He's going to give you a more general, broad discussion about lot grading. Okay, sort of a more theoretical look at it. I'm giving you kind of my practical outlook on it. Okay, so we're pretty much done for today. Keep that in mind. Start thinking about it. And I'm going to give you a tool. I'm going to do it right now. One of my students years ago developed this, and I'm going to post this. I haven't posted it yet. So let me show you. I'm going to share my screen again. And Daniel, you're going to be happy about this. Let me show you my screen. So share screen. Where is it? Sorry. Hang on, let me just set this up. I'm almost done. Okay, so let me show you this just before you go. I know some of you have to go, but let me just show you this. So one of my students years ago created this for me, and he shared it with me. Can you see my Excel sheet? So he took my diagram and he scanned it and he put it in here. You can see it? Good. Okay. So I'm going to give you the spreadsheet. So here's what you need to do here. The setback here is always 8 meters. You input it here, 8 meters. The house depth, this number here, is always 12 meters. The minimum usable backyard is always 7.5 meters. And then the lot depth, you can change it. So we had 32.7. It's going to calculate this number here. Remember 5.2 up here? 5.2, and then it calculated all of these values for you. So when you go from lot to lot to lot, you're just going to change this number. Oh, the lot depth is now 34.5. Boom, it calculates all the numbers at the back for you. Oh, the lot depth for the next one is 30.6. Calculates all the numbers for you. Oh, the lot depth now is 41.7. It calculates all those numbers for you. Okay, and I'm going to tell you this. You probably won't believe, but you're going to use this tool for every lot line as you go. And by the end of the exercise, you won't use this anymore. Okay, this is my way of teaching it to you. Okay, because the range of numbers you see at the back are very compatible, right? So as you vary these numbers, 32.7, 33, 35, you'll see these are very, very similar. They're all very close to each other. Okay, so after a while, you rely less and less on this chart, right? So you'll do the first one and you're going to use this information. Then you're going to do the next one and you're going to use this information. Then you're going to do the next one and you're going to use this information. And what you'll find is one lot line next to the next, one lot line next to another lot line is going to be very similar. So you might have like a back split, a back split, a back split, a walkout, a walkout, a walkout, a back split, a back split, a back split, next to a front, next to a front, next to a front, next to a front. It's not going to jump around too much. There's a slow, easy transition from one lot grading to another. A lot of them will be the same right next to each other. Right? You might have a whole bunch where all the numbers are between these. So you always have walkout, and then the size of the usable backyard is constantly changing, and so on. Like I said, once you're done this exercise, this spreadsheet, you won't even do it anymore, right? You'll internalize what the range of numbers are and you won't rely on it so much. But I do know, I visited students at work, and some of them still had this diagram pinned to their workstation. I still had a copy of this. I had it right in front of them on a corkboard. And then a lot of my students were still using, at work, were using this just as reference, because maybe they haven't been lot grading in a few weeks or months, so they wanted to go back and just make sure things are good. But like I said, once you do enough lot grading, this will all happen kind of in your mind, and the range of numbers will kind of be things that are very, very similar to what I did before. So you're gonna use it as you start. But by the time you get to the end, you find you'll rely on it less and less. Okay, so you have to practice this. You have to go through the lot. So again, you can see by the volume of work you have to do how much practice you're going to get. This is the one thing you'll be very, very good at by the end of this course, and certainly by the end of next semester. Okay, so that's this. So next time I see you after the break, I'm going to show you how to use Civil 3D to analyze and put your design. How to fix the profile in the assignment 3 when it extends very long to the vertical. When you projected your points, you probably forgot to change the elevation to some surface. If it's 0, it's going to, if you look at the bottom of your grid, it's probably 0. So delete the point at 0 and project it again. Remember to change the elevation to a surface. T? Okay, that's probably what happened. Okay, so please remember, assignments are due. I'm going to send a reminder probably today or tomorrow. Assignments are before midnight on Friday. I'm going to mark them over the weekend. I'll have the results to you probably Monday or Tuesday at the latest. Remember, next week there's no classes. It's study week. I don't imagine anybody's going anywhere for the week, so it's a good opportunity to catch up on all your courses. So please do as much as you can next week to catch up. Stay safe. Thanks, everybody.